All right, so here's the video for 7.3 and 7.4, basically end behavior, horizontal asymptotes and slant asymptotes. Again, it really all comes down to what degree is in the numerator and what degree is in the denominator. Now, the other thing that we can say is when we talk about end behavior, it's the equivalent to talking about the limit as x approaches positive or negative infinity. So, in these first few problems from 7.3, we're presented the question about what's happening at, in this case, as x approaches infinity. So it doesn't change that I make my end behavior model, which reduces to 3x. And even though technically I can't substitute infinity in, it's really much more about having the concept of this positive value. So 3 times this positive infinite value tells me that my limit is going to infinity. I would have already been expecting to get either positive or negative infinity, because the degree in the numerator was higher than the degree in the denominator. Similarly, I can predict based on the degree in the numerator and denominator being equal that my limit, whether I approach positive or negative infinity, is going to be some kind of number. So I create my end behavior model, which reduces to 1, and that tells me that my limit at negative infinity is 1. Similar to that first one, since the degree in my numerator is higher than the degree in my denominator, I can already expect that my value is going to go to either positive or negative infinity. So I make my end behavior model, which reduces to x. I've substituted in the wrong thing, there should be a negative there. So if I'm plugging in negative infinite values, I know that this limit is going to negative infinity. What we'll see a lot more of, although we will see limit questions here and there, is simply questions asking us to come up with our horizontal asymptotes, zeros, vertical asymptotes, etc. So I know in this number 7, whether you factor it or not is up to you, since it's x squared minus 2, which isn't a perfect square. But with no variable in the numerator, there are no zeros. With no variable in the numerator, there's no way for there to be POEs. I know that anything that comes out of my denominator only gets me my vertical asymptotes, so x equals plus or minus root 2. And again, since the degree in the denominator is 2, and effectively the degree in the numerator is 0, when the degree in the denominator is larger than the degree in the numerator, I know that my end behavior, or my horizontal asymptote, depending on how I want to discuss it, will be 0. Number 8, I needed my calculator to come up with these factors in the denominator. It was not factorable by hand. I noticed that I have overlapping values in my numerator and denominator, which guarantees that I'm going to have a POE. And so I can use my reduced fraction when I talk about the remaining values. Again, no variables in the numerator only, so there are no zeros. What came out of the denominator only was x minus 4, and x equals negative 4, and x equals 2, so those are my vertical asymptotes. And then where did we have values that overlapped in the numerator and denominator? At x equals negative 1. So I substitute into the remaining values, and I find my y-coordinate to be 1 over negative 9. And then finally, whether you look back at the original function, where the numerator's degree is 1 and the denominator's degree is 3, we would already be able to predict that we have a horizontal asymptote and our end behavior is at y equals 0. Number 9, I factor my denominator. Once again, I have no variables in the numerator, which guarantees I do not have zeros and guarantees I do not have POEs. The values that come out of the denominator only gets me my horizontal asymptotes at x equals negative 5 and x equals 3. And then again, since my numerator is effectively a 0 degree, my denominator has the larger degree, my horizontal asymptote and or end behavior is y equals 0. Denominator, I needed my calculator to get my factors. Numerator, I was able to factor by hand, and notice that I had overlapping values, so I'm going to have a POE at 2. Only remaining value in my numerator gets my 0 of negative 3 comma 0. Only values to come out of my denominator and not my numerator as well gives me my 2 vertical asymptotes. And then I use the x value of my POE, plug into a factored function to come up with my point of exclusion. And once again, I can see the degree in the numerator is smaller than the degree in the denominator, so I have a horizontal asymptote or end behavior described as y equals 0. For 7.4, I just wanted you to come up with the slant asymptotes. You didn't have to worry about doing all the other values. So I set up my division. I'm just going to erase these for a moment. I set up my division, and I asked myself, what times x squared would get me x cubed? Well, x times x squared would get me x cubed. I multiply x by all my values, so x times x squared gets me x cubed, x times negative 4x gets me negative 4x squared, and x times 4 gets me 4x. Now I'm going to subtract, or in other words, change the sign of all my values, excuse me, and that's going to leave me with x squared minus 29x minus 21. So I ask myself, what times x squared is going to get me x squared? Well, a positive 1 is. So I distribute positive 1 to x squared minus 4x plus 4. I change all my signs. And honestly, as long as this first term zeroes out, what's left over is my remainder. These values just don't really even matter to me. So I know that I have a slant asymptote at y equals x plus 1. Don't forget to include the y. So number 6, I set up the same way. And I ask myself, what times x squared would get me x cubed? X would. So I distribute x to x squared, 6x, and 5. I change my signs, and I end up with negative 3x squared minus 11x minus 8. And so again, I ask myself, what times x squared would get me negative 3x squared? Negative 3 would. So I distribute negative 3 to x squared, 6x, and 5. I change all my signs. And again, as long as this first term zeroes out, these remaining values really don't matter to me, so I don't even need to bother to write them. And so that tells me I have a slant asymptote at y equals x minus 3. Number 10, a little bit more complicated, but the same setup. So I asked myself, what times 2x squared would get me x cubed? Well, since I need that coefficient of 1, I want 2 to get multiplied by something to make it 1, so 2 times 1/2 would get me 1. X times x squared would get me x cubed. And so I distribute the 1/2 x to my 2x squared, 7x minus 15. And then I change all my signs. Now, I've got to ask myself, what times 2x squared is going to get me negative 17/2 x squared? If it helps, you could even set up 2 times what? Let me rewrite that. 2 times what is going to equal negative 17/2? Well, if I divide by 2, that tells me that I need to multiply by negative 17/4. I distribute my negative 17/4 to 2x squared plus 7x minus 15. I change all my signs. And again, as long as it's 0, whatever these remaining values is don't really matter to me. And I now have my slant asymptote at y equals 1/2 x minus 17/4. All right, hopefully that helps with the homework. Again, if you have any questions, feel free to ask in class.